Place a thermometer in a sealed room, leave a ceiling fan on high, and the temperature will not drop a single fraction of a degree. In fact, if you leave it running long enough, the room will actually get hotter. The fan motor generates friction and waste heat that bleeds directly into the surrounding air, making the space warmer than when you started. Misunderstanding this basic fact is why 60% of homeowners use their fans incorrectly. Because a fan cools nothing on its own, leaving them spinning in empty rooms wastes an estimated $2.1 billion of American electricity every year. If a machine physically adds heat to a room, the idea of using one to save on cooling costs seems like a mistake. But the savings are real, provided you stop looking at the air temperature and look at the person standing under the blades. To unlock the potential of a ceiling fan, we have to stop treating it like an air conditioner. An AC unit is designed to change the physics of a room. A fan is designed to change the biology of the people inside it. On a hot afternoon, your body's primary tool for shedding heat is the evaporation of sweat. But for that moisture to leave your skin, it needs somewhere to go. Without airflow, your body heat warms a thin film of air pressed against you. This thermal boundary layer clings to your skin. Evaporation stalls, leaving you hot. A ceiling fan shatters that blanket, driving air across your skin to strip away the humid film. This instantly creates the wind chill effect across your skin. As evaporation suddenly accelerates, every drop of sweat that turns to vapor pulls heat directly out of your body, creating a perceived cooling effect of up to 8 degrees. However, this effect has a hard limit. When a room hits 95 degrees at 90% humidity, the air is too saturated to absorb another drop of moisture from your skin. In these extreme conditions, the breeze completely stops cooling you and begins simply pushing hot, stifling air around the space. A ceiling fan works by managing your body's relationship with its environment. It relies on the physics of evaporation to provide comfort, rather than attempting to act as a mechanical refrigerator for the room. This mechanical assist dates back to 1882, when Philip Deal took an electric motor he designed for Singer sewing machines, mounted it to the ceiling, and attached 2 flat wooden blades to the rotating shaft. For over a century, most fans relied on alternating current induction motors. While they were durable, they were also inefficient. They generated excessive friction heat and usually offered only 3 speeds, meaning people often paid for more airflow than they actually needed. Modern versions replace that old hardware with brushless direct current motors. By using permanent magnets and a built-in converter, these motors eliminate the friction that used to bleed away as heat, requiring 75% less power to move the same amount of air. The blades have also been redesigned. Instead of flat planks of wood, high-end fans use aerodynamic airfoils modeled after airplane wings. These curved edges allow the fan to pull air downwards smoothly and silently, without the loud turbulence of older models. The efficiency gap between these systems is absolutely massive. While a standard central air conditioner draws upwards of 3,000 watts, a modern ceiling fan moves thousands of cubic feet of air, drawing only 50 watts, less than a single old incandescent light bulb. Over the last 140 years, engineers have painstakingly refined a crude spinning rotor into an absolute precision tool that works alongside our natural biology for a fraction of the cost of heavy mechanical cooling. To translate that engineering into actual savings, you have to follow the first rule of efficient operation, the thermostat teeter-totter. Many homeowners fall into a financial trap by running a fan while leaving the AC thermostat exactly where it was. This increases energy use by 15% because you're adding the fan's power draw and waste heat on top of the air conditioner's workload. To save money, you must raise the thermostat by about 4 degrees. The fan's wind chill effect covers the difference in how you feel, which drastically cuts the compressor time for your heavy AC unit and lowers the net cost of cooling your home. The second rule is directional. Over 60% of people never flip the seasonal switch on their fan motor, which determines whether the air is working with you or against you. In the summer, the blades must turn counterclockwise. This drives that cooling column of air straight down onto you to strip away your thermal boundary layer. In the winter, you should run the fan clockwise on its lowest speed. This pulls cool air up from the floor and pushes the warm air trapped at the ceiling back down the walls without creating a direct chilly breeze. Finally, remember the golden rule. A fan cools people, not spaces. Leaving a fan running in an empty room delivers zero comfort, only adding to your bill. When you leave the room, turn it off. By aligning your habits with the simple physics of human cooling, you can stop paying to chill empty rooms and finally take control of your energy bill.